Hello, so welcome to this cloud coaching session. In this cloud coaching session, we're going to explain how you can simple and secure your OCI multi-cloud architecture with Aviatrix. And for this, we have a special host with us, okay? So I'm going to be one of your speakers. I am Ricardo. I am a multi-cloud specialist at Oracle, covering EMEA.
Hi, so my name is Ejaz Akram. I'm also part of the same team as Ricardo, Multicloud Specialist Lead for EMEA.
And good afternoon. This is Javier Ramirez. I'm a Staff Solutions Engineer at Aviatrix. Thanks for hosting us.
So hi, everybody. I think I'm going to start with our Oracle's distributed cloud strategy. So in our distributed strategy, we have got different options for customers to choose from. For multi-cloud, our products work with other cloud providers to give you choice to deploy your solutions as required. And that's what we'll be talking more today in details. But we have got extensive presence of public cloud with more than 66 regions now across globe. We have got hybrid cloud offering where we bring cloud to you, cloud at customer with Exadata, cloud at customer for compute, are the two leading products we've got. Last but not least, we have got dedicated cloud. So customers can choose and deploy for holding their data in their data centers and just choose that and use that particular deployment model as and where required. So that also includes what we have got for our specific partner community, OCI Alloy, which can be, again, pretty much used as a dedicated cloud as a service provider offering. So what I want to quickly share here is that from multi-cloud architecture's perspective, we have developed a framework for the design and deployment of your multi-cloud solutions. That includes 4 core pillars from design perspective: the cloud core, which is basically the services you want to use from each cloud provider, the best of breed. For example, if you're going for Oracle, you might be looking for the Oracle database services. Cloud access, so how physically you connect the two clouds together, as well as maybe your connectivity required to your own premises. Cloud security, which is always the fundamental for any cloud design, but when it comes to the multi-cloud, how best we can secure that. And finally, the cloud operations. So from multi-cloud perspective, cloud operations become challenging when you have got not 1, not 2, maybe even 3 cloud providers, but your cloud operations teams still stay the same. And how do you actually make sure that those operations are consistent and available across all the clouds? So some of the multi-cloud use cases which we have seen, and they're quite common across all the industry verticals as well. The very typical one is split stack application, where customers are running a specific environment to run their key services. Could be for data management, could be for security, could be for analytics. But you could have your application deployed in a split stack mode. Workload mobility, where they distribute the workloads across the cloud for maybe price performance, as well as to make sure the compatibility. App-to-app integration, application stacks on OCI, it could be interoperating with Azure, AWS, or even GCP, with maintaining the high-performance connectivity between the applications. SaaS to platform integration. So that's another interesting use case which we have seen, and how different SaaS applications are working between the clouds to make sure the business agility as well as innovation is achieved. And finally, the data analytic pipeline. I think this is the one of the very common use cases in this modern day and time when our data is spread across different platforms, how easily we can connect them and run our analytics from different sources. So what I want to just show you now here is that with our OCI, platform, how easily we can lay down the multi-cloud framework, the four core pillars we discussed, and then how we can achieve our different multi-cloud architectures. And later in the slides, we will see how Aviatrix really helps us to capture those key four pillars from the multi-cloud framework perspective. So you could be choosing your core cloud services, network compute storage, then your physical access from VPNs to dedicated connectivity, and then into cloud operations where you can have automation with infrastructure as a code, as well as your visibility and manageability. And how the security pillar is being openly adapted or can be adapted for your multi-cloud architectures. So with that, I'm going to hand over to Javier to take you through the Aviatrix and how that helps.
Thank you, Ejaz. So Aviatrix Secure Cloud Networking is a programmable distributed system. By doing this, Aviatrix provides a consistent multi-cloud networking across all the different CSPs. It provides a consistent visibility and control from a single pane of glass. You can have a full visibility of your environment. It can provide a consistent embedded security, as we have features like a distributed cloud firewall that can be implemented across all the platform, across all the CSPs, and also provides a consistent multi-cloud automation. By a single Terraform provider, basically you can deploy all the Aviatrix environment in any cloud. Next, please. So the advantages that Aviatrix provide are resiliency, optimizes mission-critical applications and performance. As mentioned before, security, embedded security across the entire cloud network, and it's managed by a single centralized policy instead of having different bolted solutions attached to your cloud. Agility, it provides supports fully automated services provisioning from a single Terraform provider, and also provides cost optimization, lowering the cloud spend, operational costs, and also IT resource requirements, as now you have, for example, your operations team that can manage all the different clouds from a single platform instead of having to have different people learning different clouds. Next one. So I wanted to give you a high-level overview of what the Aviatrix Cloud platform consists of. So there are different components. The main component and the brain of the whole solution is the Aviatrix controller. One thing that I wanted to clarify is that Aviatrix is not a SaaS solution, is not a managed service. Basically, this is yours. So when you implement Aviatrix, this is your environment deployed within your VNet or VCN or VPC. As mentioned before, we are a single multi-cloud provider. So in order for the controller to start working with the different clouds, it interacts with the APIs on this cloud. So you have to give the controller credentials in order to start interacting with the different sections or native components of the cloud. Next one. As the controller has now the credentials to start working on the different CSPs, it can deploy micro gateways. The micro gateways, they have different type of gateways, and we follow a hub and spoke architecture. So for example, for a hub, you will deploy a transit gateway. For the spoke, you deploy a spoke gateway. And then we have edge gateways that, for example, if you want to extend your cloud to on-premise or to the branches, you can deploy an edge gateway. Next one. As the traffic passes through these gateways, we export that traffic to Aviatrix Copilot. So in Copilot is where you do all the configuration for your environment. And because we receive all the data from the gateways, then we can provide you visibility across your environment. You can see the flows that are passing through your network. You can have an extended range of tools in order to troubleshoot the environment, be from one cloud to another, or even within the same cloud. Next one. So as mentioned before, Aviatrix can connect to any cloud. As you can see here, a simple diagram where you can have your transit, your controller, and Copilot deploy in OCI, and then you can deploy gateways in the other clouds and interconnect directly to OCI for the different services and use cases that Ejaz mentioned before. And we're going to get into those use cases a little bit more. Now, following the Oracle Multicloud Framework, then you have all these different components, and Aviatrix can fit into this environment by securing the environment once you deploy the controller and Copilot. So you can secure the environment, you can have a performance cost optimization, resiliency, because all the gateways basically will be on an HA configuration, and you can deploy across multiple availability zones. Also from the physical point of view, then you can connect to the cloud via VPN. You can do over the internet or dedicated connections. From the number 3, orchestration and automation, as I mentioned, everything you do from Copilot, so it's a central location to do that, and you can use Terraform, and it can provide you all the visibility that you need on your cloud. On the number 4, under security and governance, because you have now a central location that it can be pushed all the different rules into your different clouds and your environment, so you can have compliance and data control over your environment. Right?
Okay, so and now I will jump in and I will quickly explain first all the use cases that Ejaz covered, the main multi-cloud use cases, and how Aviatrix can actually help in building these use cases. So as we explain, one of the key use cases, common use cases that we see in multi-cloud deployment is what we call, or what it's called, multi-cloud split application. So with multi-cloud split application, basically customers can leverage the specific cloud deployments while using the best of breed data management. So one basic example is a customer that wants to use PowerBuilder.net or Go applications front end on AWS and GCP, and still use autonomous database in OCI. So let's say that in a traditional environment, if a customer wants to do this, they will need to establish the connection between the two clouds, and after doing this, provide the necessary configuration to actually get this working. With Aviatrix, basically the target will be to configure spoke and transit gateways in the cloud. So in this scenario, the Aviatrix controller and the Aviatrix Copilot can be deployed in OCI, and in OCI deploy only an Aviatrix transit. Then in each of the clouds, an Aviatrix spoke can be deployed, and this way achieve this connectivity. Okay, so here in this or a common option of deploying this is just doing it with the automated deployment over the internet that Aviatrix can use. But of course, it can also use the private pre-established connections that the customer may have for an added, let's say, performance, okay, if needed. Okay, so as you can see in this scenario, the transit gateway is configured in OCI, and the spoke gateway is configured in each of the clouds. Additionally, if the customer wants enhanced security, they can leverage the Aviatrix distributed firewall. So with the Aviatrix distributed firewall, what they can do is that they can implement the security actually where they want it. So in this case, in this scenario, the security enforcement is actually done in each of the spokes. So let's say there is no need of going through a more traditional security pattern where you need to go through a centralized point for inspection. Here, you can do it in a distributed way, and it can be implemented in each of the spokes, okay? But regardless that is implemented in each of the spokes, the configuration can be done from a centralized point, okay? Which is something really helpful, particularly in these multi-cloud scenarios, okay? So the second scenario that we can see from from a multi-cloud point of view is what we covered also in the previous slides, is data analytic pipelines. Okay, so in data analytic pipeline, for example, a customer can use Power BI on Azure and use Exadata database service running on OCI. So in the previous example, in the multi-cloud split stack application, we just covered how a single Aviatrix transit can be deployed in OCI and used to connect to the different Aviatrix spoke in the different clouds. Let's say that this is the simplest deployment, but this is another option of doing this, is to configure transit in each of the clouds that are part of your multi-cloud deployment. So in this example, it will be OCI in Azure, but you can scale up to the different clouds that you have. So this way you can have Aviatrix transit in each of the clouds, and Aviatrix will help and automate the connectivity between the different clouds. And then what you will have to do is, for each of the clouds that want to connect in this multi-cloud pattern, then the spokes, the Aviatrix gateways deploying the spokes will need to connect only to the transit. Okay, so this is a simple and secure way to achieve this multi-cloud connection. Also here, you can also use the Aviatrix distributed firewall, just like as explained before, where you can enforce security in the spokes. But another option is to actually steer the traffic to any firewall that is owned or managed by the customer in the cloud. So if you have an NFV firewall in the cloud, Aviatrix can also help you doing this steering to the firewall, do the inspection there, and then just continue in the using the multi-cloud transit network built with Aviatrix. Okay, so now we can quickly jump into a demo that Javier is going to show us how you can do this with Aviatrix. Okay.
Thank you, Ricardo. So let me share my screen. Right. So just to start, before I do the demo, I wanted to share that Aviatrix can be deployed directly from the marketplace in Oracle Cloud. As you can see here, just search for Aviatrix. There are different platforms based on licenses. So typically you will select the Aviatrix Secure Networking Platform, BYOL, and also Copilot, and then you can start deploying this on your environment. So let's start with the demo. I have here Copilot, basically where you have all the visualization and configuration for your environment. We can spend hours here if I go through all the different features that we have within Aviatrix. But for sake of time, I'm gonna go into 3 different sections. So the first one is like how you deploy the gateways. The second option is how you will troubleshoot, how you will visualize your data. And the third one is how you will secure your environment. So let's start deploying gateways. So there are different ways to deploy gateways. The first one is like you can come here. As you can see, you have transit gateways, spoke gateways, depending what you want to do. For example, in this case, I have already a couple of them. If you click here, give it a name, for example, select in which cloud you want to deploy your gateway. In this case, I'm going to do OCI. I select the account that I'm going to use to deploy that gateway. I'm going to select a region, for example, here, let's do in Singapore. I'm going to select which VCN I'm going to deploy it on. I'm going to select the size of the gateway. And if I want to attach to a transit, so for example, I'm going to attach this spoke to a transit gateway that I already have. And then I can select my gateways, which AD I'm going to select, which subnet, fault domain, and then it will allocate a public IP address for that gateway. Now, if I deploy the HA gateway, I kind of follow the same approach. I'm going to deploy in a different subnet, let's say in a different fault domain. And if I click save, then it will start deploying the gateway automatically for me, and then it will attach it to the transit. So I don't have to be managing tunnels or kind of looking at the little details in order how to connect this environment. The controller will do that for me. Because this is our demo environment, I cannot click the save button, so I'm gonna get out of this one. There are also a different way to create gateways. So basically through a builder, I went ahead and kind of created this, but kind of the same approach. I have my transit, I have my spoke. I'm gonna connect the spoke to the transit. And from here, for example, like the same thing, I can click deploy and it will deploy this environment, or I can generate the Terraform code and deploy it via Terraform. For example, I'm gonna show you a different lab later on, and for that lab, I have created that lab basically all via Terraform code. So there are different ways to deploy in an automated way or through the use of visual aids. So now that we have our environment deployed, for example, you wanna see what you have deployed. This demo, as you can see, has a lot of resources in the different clouds. The colors represent each of the clouds. We have Oracle in red, GCP, Azure, and an AWS here. So on the right side, you can see I can filter stuff to find out my resources. For example, if I want to see only Oracle, I can see this here. For example, if I want to search for VMs that, for example, when somebody tells you like my application that doesn't work, for example, if I do CRM, I see that there are 3 hosts based with that name or that tag. So this diagram helps you to find out resources within your cloud. And also here you can see in the inner circle, I have all my transit gateways, and you see the green lines, that's the connection that I have created between my transits. So this will be my backbone in the cloud. The second rim on this diagram are all my spoke gateways. So you can see that the spoke gateways are connected to the transit. If I click on any of these green lights, you can see the latency on here on the right side for that particular connection. So there's a lot of information here that you can use to find out resources within your cloud. Now, the second point that I wanted to show you are how you can visualize the data on your network. So if you come here to Flow IQ, you can see all the traffic that it's passing through your network. You have different tiles here with a different information. For example, if I'm searching or trying to find out traffic about this particular IP address, you saw that it changes here, the filter. And if I apply everything now, it's related to that IP address. So you can create multiple filters here. And we have multiple metrics here as well that you can use in order to find the information that you're looking for. You can also save a view for future use of that particular view. We can have information about the trends of your traffic, where that traffic is coming through. So from here, you can have an idea where the sources or destinations are going for your traffic, and you can troubleshoot. You can see the actual records that are being sent from the different gateways and the flows of your traffic. So let me reset this view a little bit here. It's not that. Hold on. Give me a second. There you go. So this is all the traffic on my demo environment. Another thing that it's very helpful for the operations team is like, how do you troubleshoot traffic between different clouds? If you will do this, typically you will have to open maybe 10 or 15 tabs on your browser. You have to have access to the different clouds, and then you have to start one tab at a time looking at each of the different services. So for example, here I'm gonna do I'm gonna troubleshoot traffic from this source, which is one of my VMs, and I'm gonna use another one here. For example, let's see, accounting my app prod. And I'm gonna test the connectivity between these 2 hosts for TCP 443. If I run this report, which takes less than a minute, basically what it's gonna do is gonna start checking from source to destination, all the route tables, security groups, and the same thing on its destination. And it's gonna give me a report about this connection. What is in the middle, what is the latency, and if there are any issues between them. So here, as you can see, I have my destination, and here I have my source host. I have the latency that is happening, and you can see the Aviatrix gateways that traffic is passing through. Then it shows me all the information about the Aviatrix gateways in case that, for example, maybe there's a problem. For example, here I have packet drops. Let's say that there was something in the layer 1 that is causing those packet drops. So I will have that information here. And then, as I mentioned, start looking at the route tables, security groups, the Aviatrix gateways from the source, and then it moves into the destination and it does exactly the same. In this case, you see that everything is green, so the traffic it's allowed and it's passing between these two endpoints. But for example, let's say that a security group was the problem. Here it will show as fail. And here you have the security group. So you can send this report to the operations team that is managing that security group and request for that flow to be open. Now let's go to the third part of this presentation, which will be securing the environment. Aviatrix offers a distributed cloud feature, and for that we use smart groups. So smart groups is a way to put resources together. So for example, here I have, if we look at this dev smart group, basically I'm using tags in order to group the resources. For example, if I use the tag dev, I see that I have VMs, and I have VMs from different cloud providers. So 2 of them are in AWS, 1 in Azure, and I can also do based on CIDR IP addresses. So it gives you a lot of options how to group your resources. Now, once you have the smart group created, then you go to distributed cloud firewall and you start creating the policies. This view basically looks like a firewall, and it's a firewall, but instead of using the IP addresses for source and destination, now I'm using the smart groups that I went through in the previous step. So for example, if we look at one of these rules, I can see that the sources dev, I see all these resources, and the destination is also, in this case, dev, because I have resources in Azure and AWS, so I'm allowing the traffic and the communication between them on port TCP 443. Another feature that Aviatrix has within its cloud firewall, it's called web groups. So today, if you want to limit traffic to the internet, it's really hard from the cloud provider. So here you can create a whitelist. For example, in this case, I'm allowing only these resources to be accessed to the internet. And if I combine the web groups back with my rules, as you can see here, so I'm allowing traffic in this case from any RFC 1918 going to the public internet on TCP 480, but I'm allowing to go only to these IP addresses within these groups. Here under monitor, you can see all the traffic that it's passing through the network, so you can check and make sure that your policy matches your requirements. So with that, that's the end of my presentation for the Aviatrix as a whole, but I also have prepared, like going back to the use cases that Ricardo and Ejaz presented earlier, where we have a split stack. So for example, here I have a simple diagram where I have in OCI, I have deployed the controller copilot, I have a transit gateway, I have a spoke, and I have a VM here that I'm gonna use for testing. In all the other clouds, I also have VMs deployed, and this case, I have a pin running, in this case from OCI to AWS, AWS to Azure, Azure to GCP, and GCP to OCI. And so as you can see, all the pins are running. So in this simple diagram, basically, everybody's happy, everybody's talking to each other. If I go to Copilot for that particular lab, for example, under topology, that is my environment there, and I can simplify it, and I can see kind of a better picture now. So this picture here represents this picture here on my diagram. So you can see all the resources that are connected and managed by Aviatrix. Now, if I go to security, I wanted to point out a couple things for you. So The first one is that you see here I have I have multiple rules, but as you can see, only this one has a little check mark. So basically, this is the only rule that is actually working. The other ones, this is a feature that Aviatrix has, where even though that the rules are here, but it's just they are in a watch mode. So they are not taking effect, basically. They are only there. For example, you can create a rule and say, okay, I want to test this rule to make sure that nothing breaks. So you can create the rule. You can still monitor the rule because you see here, still it's logging the traffic that is passing through that rule, but it's not doing anything. So now if I want to change and enable this, I can do that via, for example, let's do which one? Give me a second. For example, AWS to Azure, I can enable this rule, which is a deny. All these 5 rules here are deny. So I can do it through the GUI, or for example, I can do it here via code. So for example, instead of watching true, I'm gonna change it to false for AWS to Azure. And also, let's say for GCP to OCI, I'm gonna change to false. If I apply this via Terraform, it's gonna take a couple seconds. And it's, sorry, I did not save that. Let's run it again. So it's gonna go one change because it's gonna change the policy. I execute, that it's done. If I refresh this screen, you see these 2 rules now have the green icons here. So this traffic now it's gonna be blocked. If I go back to my diagram here, and if I go to my ping, OCI to AWS, still working here. This one is not. AWS to Azure is the one that I block. You see the counter is not moving, still under 2661. Azure to GCP still working, and GCP to OCI should be blocked as well, and it's not moving. So via simple firewall rules, I can protect the environment, and I can go back here as well if I wanna enable this one and I wanna say turn off enforcement. I commit that change, and now let's go back to my ping for OCI, GCP to OCI, and start working. You see from 4341, which was, now the counters are moving. So with that, that's all I have for today from the demo point of view. I want to thank everyone for your time, and I want to also thank my Oracle hosts, Ricardo and Ejaz. Ricardo?
Yeah, so thank you, Javier. I think it was a good session, and we'll provide more information so that you can deep dive into this topic.
Thank you all.